Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
We're about to start the study of something truly cool. It is called kinematics. And the word kinetic means moving. You've probably heard in other science classes kinetic energy. And some people might say that LeBron James is kinesthetically gifted in the art of motion. Now, as we take notes on kinematics, we're going to try something new. We're going to be using some really cool outline notes done by an amazing physics teacher in Canada, Mrs. Brosseau. And they're called doodle notes. And so what I want you to do with these doodle notes is I want you to fill them out. I'm going to put the information on the screen. We're going to talk through these things, so follow along. The cool thing about doodle notes is you can doodle and draw pictures and color things. They're really cool when they're colored. Here's an example of one all colored in real fast. So the first topic is scalars. So on the doodle note, of course, that's already titled there. So what's a scalar? So what's the definition? This is going to go in the big box. A scalar only has magnitude and no direction. Now, magnitude's kind of a weird physicsy word. That means an amount. Now, you might notice that we've got a thermometer. Do attempt at a thermometer. So let's say, color that in up to 30.2 degrees. That's the magnitude, and that's in Celsius, and also probably direction plus a unit. And degrees Celsius is the unit. You could also measure the width of this box, the width of the box in the doodle notes, and we can say that this is 32.0 centimeters, and that's height. And the amount, or the magnitude, is 32, and the distance is, or the unit is centimeter. You could also measure the height, 15.1 centimeters, magnitude and height. And then, of course, we have up here, we've got the mass, object, right? Put something on there, and we'll say it weighs 6.2 kilograms. Again, the magnitude 6.2, the unit is kilograms. Now notice something here also important, that there is no direction. It doesn't say it's going to the east or the west or the north or the south or to the left or the right. Direction will come later. So we've learned about scalars, but now we want to talk about the second half from this page, and that is a vector. And a vector has direction. So it not only does it have direction, it has magnitude. And a vector is usually represented by an arrow. So you can say 3.2 meters, we can say west. All right? Or we can say 4.6 meters per second. That would be a speed. Meters per second, we'll talk about that later. And we'll say to the northeast. This is the idea, right? Actually, probably would say this would be east, right? As it's drawn here. So you can change, you have both a direction and you also have a distance and a unit. So it's got all three. So the definition of a vector is it has both direction and magnitude. Now, one thing you see on the doodle sheet is you have this thing we call a spring scale, and then you put a weight on it. And this measures force. We'll learn more about force. Forces are measured in something called newtons. And you can say that it has, 2.0 newtons downward. The force is downward from the force and the acceleration of gravity. Next up, I'm going to ask you the question, vector or scalar? And these are the ones at the bottom of the sheet. I'm going to ask you a series of questions on Edpuzzle and see if you can get them right. So let's see if you got them right. So which ones are vectors? Remember, vectors have direction and magnitude. They're going to be ones that have magnitude, and all of these have magnitude. The question is which ones are the ones that have also direction. So this would be a vector because we've got down. This one is a vector because it has left. As a side note, the direction is almost always put in brackets. So brackets are kind of a dead giveaway. This one is to the east. This one is to the north at 120 degrees. I see to the south. And the rest of them are scalars. So about 4 or 5 that are vectors, and the rest are scalars. So now you know the difference between a scalar and a vector.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.